Okay, so welcome everyone. I would like to introduce the speakers first. My name is Pavel. I'll be moderating this call today. Welcome to the Gardener community meeting on 18th September. We have two speakers for today. We are going to have first Rafael. He is going to share with us what happened with Gardener over the summer and what is the latest news in the releases that were done in the last few months. Then we're going to hear from Stefan a bit about what's his experience with running Gardener in production for more than a year. And with this, I would like to hand over to Rafael. So Rafael, if you like to take over the screen sharing.
Yep. 1 second. See it?
Yes, works. Thank you.
Yeah, okay. Yeah, so hello everybody. I will quickly summarize, hopefully not too long, the major themes of the last 3 releases that happened during the summer holidays in August and September. So let's start. The first one is the change of our logging stack. We were using Elasticsearch, Fluentd, and Kibana earlier since I think 2.5 years already. And with this PR, we have replaced the stack with Loki. For certain reasons. Most prominently because we are also using Grafana and Prometheus in our stack, and Loki was the natural choice also to get rid of some other scalability issues that we saw with the other stack. There's also a dedicated blog post if you haven't seen it yet, where this logging architecture here with Loki will be explained in detail and highlighted in a dedicated post. Then the next change was about cluster identities and DNSOwner objects. So this one is for the feature that we plan to introduce in the next weeks and months, which is the control plane migration of a shoot control plane from one seed to another one. And for this, we need stable identities of the various clusters. So now the garden cluster has its own identity. All the seed clusters get their own identity, and also all the shoot clusters. And those will be saved in the status fields. And the important thing here is if you update to this version, then you also should configure this new flag for the Gardener API server with the identity that just the name that you want to set for this landscape. And the DNSOwner objects is a custom resource that is created as part of the shoot reconciliation flow, similar like the DNS provider and DNS entry objects, and it's used here to declare the owner of a certain DNS record, so that it can be easily switched over when the control plane will be migrated. Then the next change is about the project resource. Earlier, we only had 2 roles, which is admin and viewer. And now we have also introduced the UAM role, which is user access manager. And this basically is backed by a custom airbag verb. And only with this role, it is possible to change the members of a project. So earlier, I think all admins could change the members and delete each other. And to implement certain compliance aspects, this role here can be used to limit the access to only certain people and project members. Just, by the way, just interrupt me if you have questions to a certain change or comments. Then I continue with the node local DNS feature. It's a new alpha feature in the Gardenlet. It deploys the upstream node local DNS daemon set to the shoot worker nodes if this is enabled. So it's, as said, it's a feature gate in the Gardenlet. So if it's enabled, it will happen for all the shoots. At the moment, it cannot be enabled or disabled per shoot. yeah, it's to optimize the DNS performance, because with core DNS, like we have it at the moment, we sometimes see, also a little bit depending on the workload, of course, but we see sometimes load balancer issues and other bottlenecks that the node local DNS can circumvent. If you want to try it out, I think at the moment there's still an open issue with network policies, but yeah, I think in the next few weeks this will be resolved and then hopefully be graduated to beta. Then we have further worked on the configurability of the control plane and the kubelet. So for the kubelet, it is now possible to set the system reserved and kube reserved settings. And for the API server, you can now configure the default and specific watch cache sizes, which might be especially interesting for shooted seeds, which usually have a lot of watches depending on the size, and where you might want to increase this to get more stable watch connections. And also again about configurability in the shoot spec. Now, yeah, more for end users, it's now possible to configure the machine controller manager. So like the train timeouts or the health timeouts for certain worker pools. Yeah, and this is to further or to better adapt the machine controller manager behavior to the deployed workload in the cluster. Sometimes it maybe makes more sense to have a large train timeout, sometimes a smaller one is better, and so on. And then we have already in the release 1.7, I think, we had introduced a cached client feature gate and consolidated the clients to a single one per seed cluster and per shoot. And this feature gate is also still alpha, but we have introduced and actively worked on it. So there are a few improvements here. Yeah, one was to use the cached client for the shoot care controller as well, to save some network I/O. And then in the second PR here, we disabled the cached client for shoots directly, because the gardenlet is running in the same cluster anyways, usually, like the control plane of the shoots, and can talk to the API server's cluster internally. So here it isn't, or it doesn't make a big difference to use a cache, and that's why we disabled it here again. And for AWS, we have enabled the volume encryption by default for the root disks. When you create a new worker node, the root disk will be encrypted now. For existing nodes, this will only happen when they are rolling updated the next time. And generally, there are, I think, certain machine types in AWS which don't support encryption. So you can still go ahead and disable this feature in the respective flag in the worker pool configuration. Right, then we have a liveness probe for the Gardener API server. So that was an improvement in the Gardener Helm chart. And I think what is not listed here is that we meanwhile also have a readiness probe. So both improvements together should lead to better rolling update behavior when the Gardener API server is updated to a new version, for example, or scaled up or down. Okay, and then we had a change in the port configuration. The specific change is not too important. I just want to mention here that it is made for OpenShift to make Gardener working on OpenShift. And I think this is also already validated that this is possible in general. There were also other improvements to other extensions with respect to, for example, airbag configuration that is necessary for OpenShift. So this would work as well. All right. Then change for user experience is here the validation for our container runtimes and extensions. So we have introduced the support for containerd a couple of months back, but because it's machine image specific whether containerd is supported or not, it was in the past a little bit difficult for end users to figure out whether they can now enable containerd for their worker pool or not. And here with this pull request, this information is now exposed in the respective cloud profiles, which also leads to better validation from our side or from Gartner's side to prevent people from misconfiguration. And we have introduced a new controller in the Gartner Controller Manager for shoot events. So there were already a few events that were written by Gartner, for example, when a reconciliation operation or a deletion operation is started. But we were using the native Kubernetes event objects here, and they are usually garbage collected after 1 hour per default. And with this controller here, you can extend the lifetime of only the shoot events to a certain higher time, while all the other events can still be garbage collected earlier if you don't want to keep them as long as the shoot events. And I think with this change, we also introduced new events like information when the maintenance happened or automatically hibernated or woken up due to a hibernation schedule, for example. So you can better track why a certain update was happening to a certain shoot. And a small change, the log, I think very soon in the beginning. In the past, it was one of the last steps, but sometimes it's helpful to have the logging stack already. For example, when the creation flow gets stuck in a certain point, to have the logs of the various components running there and to debug issues. So we moved it earlier in this creation flow now. Then we have added 1.19 support in Gartner and also all the provider extensions that we maintain in the Gartner organization. I think one maybe important fact to know is here that we also have added a dedicated Hypercube repository because the Kubernetes community doesn't build Hypercube anymore, but we rely on this image because it contains the kubelet binary, for example, and we use it to get the binary to the worker nodes. And for 1.19, we are now building this image on our own. Just contains the kubelet and kubectl binaries. And Then certificate rotation for the gardenlet was added in an automated way and enabled by default. So this is more or less the same like the TLS bootstrapping and certificate rotation for the kubelet. So we use the certificate signing request API of Kubernetes to get it to a client certificate and also to rotate it again when it, I think, reaches 80% of its expiration date. All right, then we have made some improvements in our monitoring alerts. I think mainly better grouping, less false positives, and in the end, this should result in less alerts and more consolidated with the relevant information. Then again, a validation improvement here. So it's now no longer possible to delete seeds that are still in use by shoots. So this is also, or was not possible before. At least the deletion didn't really happen at all, but it was possible to set the deletion timestamp. And this is now explicitly forbidden because it comes with certain side effects and other consequences that we usually don't want in a running system. Yeah, I think these were the main themes that I wanted to highlight. There are also these 2 blog posts here on gardener.cloud, where these changes that I just presented are also summarized, and a short explanation is added as well. So you can go there, also check out the PRs that are linked, and get more information if you're interested in certain changes. That would be it from my side. If you don't have any questions, I would hand over then back to Pavel.
Thanks, Rafael. That was a great overview. So I think if there are questions, we can take them now. I saw already in the chat there was a discussion around the node local DNS, and Hardik took the answer. So thanks for that. If you would like to add something on that, you can do that. If there are other questions, please feel free to unmute. Okay, then in this case, I think we can continue with the next topic. Thanks, Rafael, for presenting that today and taking the time to collect the summary of the last releases. I've put in the chat also the links to the latest books, and I will add them also in the Slack later on and in the video upload. And with this, I think we can continue and hand over to Stefan. So Stefan, the stage is yours. I'm going to share the screen for you so that you can save the efforts that we talked about earlier. So give me just a second because my Zoom window is gone. Okay, so here it is. Okay, so can you please confirm you can see the screen? Should see a presentation full screen. Yes.
Yes. Pavel, you have to hand over.
Yes, exactly. Let me give you control. Okay, I believe you have control and you should be able to work with the deck. You just
okay, yeah, works. Thanks, Pavel.
Super.
Oops. No.
Should work. Yeah.
Okay, now it works. So thanks for letting me show what we have done in the past year. My name is Stefan Majer. I'm working for Excellent Technologies, a small company, consulting company in Munich, and we do all the work actually for the Finanzinformatik Technology Service. So who is involved? The Finanzinformatik Technology Service is a data center provider for banks. They're mainly located in Munich, but also have some locations in other parts of Germany. And the main goal of this company is to serve as a data center provider for the Landesbanken and a lot of banks from the Sparkassen Group in Germany. And it's IZB regulated data center provider, which is a very important point, which impacts the way production of data center services has to be done. Excellent Technology is, as I said, a small consulting company from Munich, focused on software development, and we're working together with FITS as a long-term strategic partner. So what is MetalStack? For those who haven't heard about MetalStack, short introduction. It's an open source software to build bare metal platforms, built with the software-defined data center in mind, especially to provide Kubernetes as a service. With strong focus on security, multi-tenancy, and best-in-class networking, which are all required aspects if you want to run regulated workloads for banks or governmental workloads, for example. You can think of MetalStack of a cloud provider for your on-premise data center resources. Sometimes takes a while. So, what was our journey from in the last 1.5 years? So we started to build Kubernetes as a service on bare metal back in 2018, in the fall of 2018. We were asked to make it happen that FITS is able to produce Kubernetes on scale for all of their customers, and we started to look at the opportunities, how to do that, and decided, I explain why and how, to build our own engine to provision Kubernetes worker nodes on bare metal machines. It took us about 4 months to be able to provide the physical machines in an automatic manner, and quite after that we talked to the Gartner guys and integrated our API into Gartner, and in fall 2019 we had the first customers running on that, and real production was started at the very first beginning of this year. And since then, we enhanced the portfolio on top of that, like we have an S3 running on top of Kubernetes, on top of our bare metal machines. We have our own website and so forth. So just a few arguments why Kubernetes on-premise. Because of, as I said at the beginning, regulatory requirements. It is possible to run banking applications on the major hyperscalers, but it's a very difficult approach to get the documents signed in a manner that the ICB is able to allow these, but there are still concerns about the data residency. Where are my data located? And price performance ratio is much better if you have running your workloads in your own data center, and you do prevent the vendor lock, which all of these hyperscalers can do very good, are very good in to lock you into their own platform as a service or Kubernetes as a service offerings. For some reasons, latency might be an issue if you think of trading applications and so forth. And why should you do that on bare metal if you run your Kubernetes clusters on-premise? Because you will get a reliable performance and you will not have any noisy neighbor issues. Imagine you have running 2 different type of workloads on a virtualization machine, which might intercept each other's. So this is not the case if you have a dedicated physical machine for your workload. And in actual times where you have massive disk and network speeds available, 100 gig networking or NVMe disks, it's a loss of speed if you virtualize on top of them. You will also mitigate the well-known Spectre meltdown CPU in the whole landscape. So getting the virtualization out of the story reduces bugs and simplifies the deployment. So that's the reason why we thought running Kubernetes on bare metal on-premise is a good idea. But automatically create worker nodes on physical machines is not an easy task and was not available at that time. So we created our own, and this is a short overview what we ended up doing. So we have physical machines from Supermicro and from Lenovo, for example, and open compute compatible switches with open source operating system on top of them. And our Metal Stack API provisions all these infrastructure components and provides an API in Go. And on top of that, Gartner is able to produce Kubernetes clusters out of these bare metal machines. And from our perspective, this combination is a real alternative to VMware and OpenStack and other virtualization technologies, and is a fully open source stack in your data center. So I will give you in the next few slides a short overview what we did exactly in the last year, so you can get a more in-deep view what happened in our team. As I said, we started from scratch after we had a look at some offerings in the open source space for bare metal provisioning, and we found no suitable software which has a cloud native approach. There are some solutions out there, like from OpenStack. There's one project which does that, but this is 10 years old. Ubuntu does have Mars, but have also some downsides. And Tinkerbell from Packet was not there 1.5 years ago, and they're still in the process of making it suitable for all the use cases we expect. So we started from scratch, wrote Metal Stack, and it took about 4 months till we were able to provision physical servers, and it took about a minute to provision a bare metal server with a running operating system and fully functional network connectivity. And we think this is great. It feels like virtual machines, but it's not. And right from the beginning, we had a Go API available. I always share the GitHub links to what I'm talking about. And this was in the beginning of 2019, and at that time Gartner and Machine Controller Manager had only the in-tree cloud provider mechanisms available, so we forked both of them and built the images by our own, and made it in that way for the first couple of months. After that, the people at the Gartner team did a lot of work to make the Gartner out of tree cloud provider able, and we start to implement our own so-called extension provider. It's the Gartner extension provider Metal, which decouples Gartner from the concrete cloud provider implementation, in our case for Metal Stack. The same happened a bit later for the Machine Controller Manager. I will talk about that later. We also have our own operating system image distributions based on Ubuntu and Debian. The difference to vanilla Ubuntu or Debian images that we use Ignition from CoreOS instead of Cloud Init for the Cloud Init process, and therefore we need a separate extension which is responsible to create the Cloud Init configuration, which Gartner uses to deploy the Bootstrap shell scripts and process into the machine our Metal extension, OS Metal extension, is responsible to do that for our Ubuntu and Debian images. Networking is also slightly different to what Google or Amazon does. We have our own BGP, routing to the host-based network topology, and therefore we have to modify the way Calico, which is the actual default networking implementation, Gartner uses, and at the beginning we have to fork it and modify it to make it work together with our BGP speaker, which is running on every physical machines. But this work has been merged upstream some months ago, and thanks Adel for helping. He left the Gartner team a week ago. We also have to implement, as we are a cloud provider, our own cloud provider manager, which is responsible to bridge the gap between the infrastructure and Kubernetes for load balancer and IP addresses of the worker nodes and so forth. And our cloud provider manager is Metal CCM, which also enables us to have a service type load balancer working automatically. It is based on the BGP approach we have in combination with Metal LB, which someone might know. So with no additional hardware load balancer or single point of failure in our whole infrastructure, we can provide a service type load balancer to our customers. Storage is also a very complicated topic in Kubernetes, as you all know, might know. And our physical machines have very fast local NVMe disks, all of them. And to make them usable in a Kubernetes native way, we also have to create a CSI driver, which leverages the local NVMe disks and create PVCs with logic volume manager. And it's also usable in other environments where you want to use local disks as a PV in your Kubernetes cluster. It's also some other users are out there which are not Metal Stack users. And a few weeks ago, the machine controller manager learned also out of tree. So the in-tree cloud implementations can be split out into a sidecar. And since 2 weeks, we have this out of tree sidecar supporting Metal Stack for the machine controller manager. This is not in production yet. We hope we can go with that into production in our deployment next week. This is a great step forward because the machine controller manager was our biggest fork, which was quite a bit of effort to maintain, and we're happy to Hardik and Prashant, thanks to you guys for support, that we're now able to maintain that out of tree. Another network topic is the control of network access to and from Kubernetes cluster to the outside world. In our environment, there is a dedicated machine in front of every Kubernetes cluster. It's also a physical machine, the same as a worker machine, but slightly different deployed. And on that machine, there is a controller running, which reconciles a cluster-wide network policy resource, which enforces which creates firewall rules to control the access to and from the Kubernetes cluster. Almost the last slide. because we are a cloud provider and we have our own data center, we are also automating the whole deployment of all our components into the data center with Ansible. This includes, for example, the out-of-band management network and infrastructure in the data center, the switches and routers for the initial configuration, all the subsequent configuration modifications which are necessary on machine creation or deletion are done with our metal stack components afterwards. And the metal stack control plane, which is running on GKE, is also deployed with Ansible. So this is a huge amount of Ansible roles. Part of them are open source metal roles, which are responsible for the metal stack control plane parts, and these are the parts which are running on the switches, for example. All these roles are also made open source. There are, of course, a lot of other stuff which is not of public interest. For example, how we deploy our out-of-band infrastructure. These are kept internally. We have in total about 50 repositories actually on GitHub, and roughly the same amount of repos in our internal Git hosting, to just give you an insight or an idea of how much work we have done in the past 1.5 years. We actually try to have a bi-weekly releases to production where we update metal stack and the Gardener components in the whole fleet for all data centers. Currently, we have 3 data centers for production and 1 very small setup in a test data center. Production is actually located in Nuremberg, Stuttgart, and Fellbach. And in every data center, there are about 100 physical machines with in total 7,500 CPUs, 28 terabytes of RAM, and almost a petabyte of local NVMe storage. We also have in total 36 storage servers for our S3 offering, which is also running on Kubernetes, with roughly 3.5 petabyte of hard disk, traditional hard disk storage. All is 100 gigabyte per second network switching infrastructure, and all servers are connected with 2 times 25 gigabyte per second. So it's a quite fast setup, very up to date. We are quite happy with the performance we get out of these machines and network. And yeah. What's up next? We're currently in the process of providing persistent volumes. So the actual storage solution is local storage, which not survives node replacement, obviously. And therefore, we have evaluated NVMe over TCP solution. We will go to in beta in November, where we provide a small amount of storage in every data center, which will be attached to a physical machine over the network with the NVMe protocol, which gives very fast physical volume, which survives the node reinstallation or pod relocation to another worker node. What we also would like to have, especially for our worker nodes with a lot amount of local storage, is a reinstall instead of replacement in case of major Kubernetes upgrades. Our Metal API, Metal Stack API already have a reinstall feature where you can provision the machine with a newer version of the operating system, but the local data will not be overwritten, and this will have to be implemented in all three components. I think it is required to modify Gardener, the extension provider, and the machine controller manager. IPv6 and Cilium are kind of similar issues because we are short in IPv4 IP addresses. We are keen to support IPv6 at least from the outside view, but it's a big issue because it touches all of the components, beginning from the networking, base infrastructure to firewalling and Kubernetes and Gardener and so forth. Gardener already learned SNI for the API server and reverse tunnel, which preserves or saves a lot of IP addresses, 2 for every Kubernetes cluster or shoot. This will be done in the next few weeks. We'll try out to set up these feature gates and enable them for further for new shoots. We have also have to support more different hardware vendors. Actually, we are able to provision our software on Supermicro and Lenovo servers, but more to come. This is very difficult and ugly part because of the differences between the behavior and for different hardware vendors and the bugs in firmwares and so forth. We also want to support another operating system for our switches. Actually, we only support Cumulus Linux on our switch hardware. Sonic is a development driven by Microsoft. It's an open source, fully open source operating system for the switches, and is seen as the successor for the next century in the networking space, and we want to support that as well. Kubernetes in Kubernetes, aka KubeVirt, makes sense to be able to provide even smaller shoot clusters with smaller worker nodes, because actually the smallest worker node we can provide is the physical machine, and it might be of interest to have even smaller machines for development purpose, for example, available. To end my presentation, I want to have some closing notes, and I have to say that we are really thrilled by the kindness of all the people in the Gardener developer community, and we really are glad to make this decision back in 2019. We had no major issues, neither technically nor in the relation between the both communities. So this was a really good choice. But we have some pain points. These are mainly related to the hardware part. So firmware and BIOSes are all proprietary. We don't have access to the source code, and they are full of bugs which sometimes are never get fixed by the vendor. And the different vendors, Supermicro and Lenovo, are behaving different. If you want to, for example, power on or off or boot from network or hard disk, this is always different. Even if they promise to support the IPMI or Redfish standard, it's always different. And to circumvent that, we started to begin to create a library in Go, which does all the ugly hardware abstraction factor out, and we are currently doing quite a lot of work in that area. We hope, on the other hand, that sometime we have open hardware accessible even for smaller companies like us. The big hyperscalers like Facebook and Microsoft already do use open hardware, but these hardware models are not already or not easily consumable by traditional data center buildings, for example, because they use a different form factor and so forth. Yeah. So I would like to close my presentation with some pointers to the involved parties, and thank you for listening. If you have any question, please go ahead and ask.
But, oh, yeah, sorry. Go ahead.
Thank you. I have one question. You claimed that on the second slide that VMware and OpenStack are kind of obsolete, but it means that, I mean, OpenStack and VMware are doing both actual virtualization, so you can split the big fat server between multiple clients. But obviously your setup presumes that a single server, whether it be big or small, is dedicated to a single client and not virtualized, and it runs a single kubelet. So in this the best solution to split the server, do you already run any virtualization network stack?
You're hard to understand. Can you rephrase your question, please?
Yeah, I think you were breaking up, Alexander.
Now he's gone.
But I think the question was that the big machines that you use, I think the bare metal servers are pretty big. And so virtualization will split them up, and so different users can use them with smaller machines.
Yeah. This would be the goal of one of the topics we want to address next. So run Kubernetes or worker nodes inside Kubernetes with kubelet to circumvent or to address this issue for some customers or use cases. For most of the current customers, the size of our machines are quite suitable. So we have 24 cores, 100 gig RAM, and for most of our use cases, this is a quite good size with 2 or 3 worker nodes. Most of the users are happy. But there are use cases where you need smaller machines, and therefore we want to use kubelet.
Open with switch, or did you already implement something like this?
No, we haven't implemented. We will start that in the next couple of months, I think, together with the friends from SAP.
If you allow me, this is Stoyan Rachev speaking regarding KubeVirt. There is a parallel effort ongoing to integrate KubeVirt with Gardener. So there is already an extension for KubeVirt in development. From my perspective, in order to use that in the Meadow stack, the efforts, we could combine forces, so to say, and then what would be required is just to have a Meadow stack cluster as the so-called provider cluster for our KubeVirt extension.
So the underlay and the overlay cluster. Yeah.
Exactly. So if you're interested, just ping me, and we can have a meeting, talk about it, show you what we have. I think I will be, or somebody from the team, me or somebody else, will be presenting that in one of the next community meetings. So yeah, that's coming.
Appreciate. Yes.
Yeah, hi, this is Vasu. I just wanted to mention also, Stefan, thank you for your presentation and the update. We in the background, the Gardener and SAP have been also collaborating in open source with the team of Stefan Majer and the Finanzinformatik.
services team. Essentially, we also have a hardware setup, a POC, so to speak, in our data center because we find it very intriguing. And we have obviously a couple of other requirements on top, which we want to also make available to the Gardener community using the the channel of the metal stack. So this is a very interesting, nice open source collaboration which happened kind of out of the blue. If you put things out in the community, you contribute, somebody else contributes, and things happen. I think I want to ask one question, Stefan. I think we're doing this. We're mostly because we are consuming ourselves the technology. You're consuming metal stack. We're not the typical vendors, so to speak, of this type of technology. If somebody would be interested to have the metal stack running in his premise, are you considering a commercialization of metal stack? In the open source realm, of course, can he get help from you to set it up like we did, but in an early stage? Can you talk about that a little?
So we developers are mostly from Excellent, and if someone is interested in getting support running metal stack on in his own data center, we are thinking about doing so, providing support, but this has not been finalized yet, and because of the lack of parties doing so,
Okay, so it's demand based now.
Yeah,
right? We create demand, then it'll happen. Okay, great.
But we have the force or the people, the required people who can do that.
Perfect.
Are there any questions out there?
Could you maybe give me an idea why you decided to go with Gardener and not with a cluster API provider bare metal? Like what's wrong with cluster API and why Gardener is better?
Yeah, I have a strong opinion regarding cluster API versus Gardener. Cluster API is focused on producing the control plane inside the group of worker nodes. In contrast, Gardener has the idea of a shared control plane, which saves a lot of resources and creates a better availability and maintainability of the control plane. It would not be possible to get scalable Kubernetes as a service offering if you have to rely on threefold leaders inside the worker nodes. It would be not possible. There are use cases for cluster API in virtualization, for example. That's the reason why most of the VMware people are driving cluster API. But it's not suitable to create scalable deployments.
Maybe I can also add a bit there. So
thank you.
I have been generally involved with the progress and the developments going on in the cluster API since quite a long time. So I would rather look at cluster API as a vehicle to enable such provisioners. So one of such provisioner is, let's say, kubelet, right? Then recently Telos was introduced, and then we also plan that in some short-term future we will also have a Gardener provider available there. So essentially, cluster API would be an abstraction on top. That's one thing. The other part, I would say, it's still an alpha stage, so we still see the issues in the cluster API where there are minor bugs here and there, and things are still not production ready. So that would also hold back the decision for some more time. And that's how I would look at it. So I wouldn't say that you can completely reject that idea, but in general, you would see that in future you would be using cluster API, but also using the same creating Gardener clusters. So that's where they will align eventually.
Yeah, maybe I can add in the Slack community there of Gardener. If you go there, there are a couple of questions similarly asked, and there's more detail to that. But essentially, what you need to, I think, see, you have to differentiate between the API specification and the implementation. And currently, our specification, the Gardener Shoot specification, which think of it as being compatible to a future cluster API specification, is semantically much more rich. We can twiddle. You saw the delta, which Rafael talked about. We can twiddle with all kinds of knobs, which are just not available in cluster API today. And that there's a reason for that, because we're running Gardener in production since a couple of years. Right, and once the specification has turned beta or is generally available for cluster API, we can definitely merge many of our attributes of semantic richness into a standard definition. And then the question is, okay, can you really then, what are the qualities if you change the provider? And kubeadm versus Gardener, I mean, there are worlds in between. I mean, just run it in production and see how many PagerDuties you'll get. That's essentially the gist of it, right? It's not an or question, it's an and, but the timeline is important. When. All right.
Yeah, cluster timeline is really slow. I can agree.
Oh, but thanks for the question. It's a good, yeah.
Super. Do we have more questions? I checked in the chat. Seems that we are good. Okay, then looking at the clock, I think we are right on time. Thanks a lot, everyone, for making the time today. The slides will be available in the Google Docs. And I'll put in the Slack the link to the video recording and to the slides when we upload them. So thanks, have a great day and have a great weekend.
You too.
Thank you.
Thanks.
Thanks, Pavel.
Bye-bye.
Bye-bye.
Bye. Thanks. Bye.